All right, welcome back. So now we are going to finish up chapter 8 by talking about thiols and sulfides. And so the reason they're placed here is because if you look at the periodic table, sulfur is right below oxygen in the periodic table. So sulfur ends up having a lot of similar reactivity as oxygen. Um, and it's not to say that sulfur compounds aren't important. They are very important. They're just not as common or as important as the oxygen compounds. So we spend a lot more time talking about oxygen than sulfur. So for ethers and alcohols, there are the sulfur analogs of those. So let's start with the sulfur analog of the alcohol. So the sulfur analog of the alcohol is known as a thiol. So if I replace the OH of an alcohol with a SH, that's a thiol. So a thiol, the way you name thiols is you basically have the alkyl group and you put thiol on the end here. So there's a new suffix thiol. So the alkyl group, you find the longest chain alkyl group with the SH. You name that alkane chain and add thiol. So ethane thiol, cyclohexane thiol. Now this is an example of if there wasn't this here, you could call this benzene thiol. But because there's this here, you can't call this benzene thiol. So then we have to name this sulfur as a functional group. So when we're naming this as a functional group, we call this a mercapto functional group. So then this becomes, we're going to use the parent name of benzoic acid, and then this is meta-mercapto benzoic acid. Okay. For sulfides, so the sulfide is the sulfur analog of the ether. So these would all be ethers if you replace these sulfurs with oxygen. They're not, so these are now, we have sulfur here, so now we're going to have, we call these sulfides. So just like with simple ethers, so you can have simple sulfides. You name both alkyl groups followed by sulfide, dimethyl sulfide, methylphenyl sulfide. Now this isn't a simple alkyl group, so what we have to do is you have to treat this as a functional group. When you treat this as a functional group, you name the alkyl group you name the simple alkyl group followed by thio. So this is a methyl thio functional group. Now, then you name this as a cycloalkene molecule. So 1, 2, 3, cyclohexene. The methyl thio group is at 3. So 3-methyl thiocyclohexene. So we're adding two suffixes for thiols. We have thiol, and if you're going to name it as a functional group, you have the prefix mercapto. For sulfides, we're adding a new suffix sulfide, and then if you're treating it as a functional group, you have alkyl thio. Now let's talk about how we make thiols. So the way you make thiols is very representative of how you would make alcohols. So for example, the way you could make a thiol is if you think about being able to make the carbon-sulfur bond if this was nucleophilic and this was electrophilic. So just like making alcohols, if the oxygen was nucleophilic, like doing an SN2 reaction between hydroxide and alkyl halide, you can do the same thing to make the thiol. You can take a sulfide and react it. You can take sulfide and react it with an alkyl halide in an SN2 reaction. So the way this works is you would take the sulfide, react it with and this works best obviously for primary alkyl halides, and then you do the SN2 reaction and you get the thiol. Now the alkyl thiol product can undergo further reaction with the alkyl halide to give a symmetrical sulfide, which is why sometimes this can be in poor yield. So this reaction can be a little difficult to stop. To make sulfides, it's a very similar reaction. You take something called, so now this molecule is called a thiolate. So if you take a thiol and deprotonate it, you make the thiolate. That S- can react with primary and secondary alkyl halides in an SN2 reaction to give you a new sulfur carbon bond to give you the sulfide. Thiolates are really good nucleophiles. They're better nucleophiles than oxygen. So sulfur ends up being a better nucleophile than oxygen, mainly because for its size. And so sulfur is very reactive toward being a nucleophile. You can also oxidize thiols. The oxidation looks a lot different than the oxidation of alcohols, though. So if I take a thiol and I put it under oxidizing conditions. So this is a weird oxidant. I2 is an oxidant. If I take it, I can oxidize the thiol to make a bond between two different thiols through the sulfurs. This is called a disulfide linkage. This disulfide linkage can be reduced. So again, metal with some kind of hydrogen source, that's going to be a reduction. So you can go back and forth. You can oxidize to make the disulfide, and then you could reduce to make the thiol. The reason why this is important is because biologically there's a number of amino acids that contain sulfur, and the reason why that's important is because you can, in a protein, those disulfide linkages can provide extra rigidity for the protein. In this particular case, what we're seeing here is a lot of intercellular reactions. They take place through a disulfide linkage, right? So this is a reaction where you have glutathione under peroxide oxidizing conditions. You make the disulfide linkage, and then you can go backwards with the reductant FADH2. All right, so that's the end of chapter 8. As you probably realize, there's not that much with the sulfur analogs. Know how to name the thiol, know how to name the sulfides, know how to make thiols, know how to make sulfides, and understand that oxidation reduction sequence of thiols. Thanks. That's it. Let me know if you have any questions, and have a great day.